2, 1. Okay, so here's the script for linear momentum. This is the first section of the next chapter. Momentum is a word we hear a lot, particularly if you are into sports. We used to call momentum Big Mo when I was coaching. Basically, it was when a team was doing okay or not so good, and then all of a sudden gets a few quick, really good plays, and all of a sudden there's nothing stopping because the confidence is up. They just keep moving forward and put the other team on their heels and eventually either win or come really close to winning. That is a sports analogy for the term momentum. In football, if you want to take a look at another example, if you have two players coming at each other, one is a ball carrier, the other is a tackler, and let's say they're both moving at the same speed at each other, but the tackler weighs more than the ball carrier, then when the tackle is made, the tackler is going to push the ball carrier back because he's got more momentum. However, if the tackler is bigger and the ball carrier is smaller, but the ball carrier is moving twice as fast as the somewhat heavier tackler, when they collide, the ball carrier is going to push the guy back because he has momentum. So it's a combination of mass and volume. In fact, the classical physics definition of momentum is mass times velocity. Now, because we have an m here, we can't use m for momentum. Newton was the first guy to come up with this concept. And again, as I said before, these people, way back when, the very famous scientists, were into the Greek and Latin languages because a lot of the original science and mathematical concepts came from those two civilizations. So he used P. He never explained why, but a number of scientists have surmised that P came from the Latin word parere, which meant kind of an impulse, a push. And so the P stuck at some other, for whatever reason, mainly because there's no alternative to M, which stood for mass. The example that's talked about in the script is about two protons. And they are traveling towards each other. So there's going to be this football collision that's going to take place here. And the question is, what is the total momentum between the two? Not which one is going to carry where, but what is the total momentum? We know that the mass of a proton, this is in your front jacket of the book somewhere, or inside flap, I believe, is 1.67 times 10 to the negative 27 kilograms. And that is true for both. Let's say proton 1 has a momentum, we'll call P1, is equal to this mass, 1.67 times 10 to the negative 27 kilograms. And then it's going to multiply by velocity. Well, let's say P1's velocity is 340 meters per second, going towards the other proton, okay? Well, as you can see, if you multiply these two together, you're going to get a value for the momentum. And if you take a look at the label for that is kilogram meters per second. And boy, does that ever scream a need for some scientist name to replace this semi-clunky label. But no, there is no label for that outside of just kilogram meters per second. So that's what we're going to use from here on in. The second proton is 1.67 times 10 to the negative 27 kilograms times the velocity of the other. Now, here's where we're talking about velocity. We're talking about objects going at each other. So if we're going to say that this is a positive velocity, then the other one's going the exact opposite direction. So we're going to make that a negative velocity. And that negative velocity, the example that I gave there in the script, is 450 meters per second. So what I'm going to do is instead of adding, multiplying these out separately and adding them together, I'm just going to go ahead and put this all together in one addition problem. So I'm going to say P1 plus P2 is going to equal whatever answer I get on my calculator for this. But because there is no specifics as to which one is truly positive and one is truly negative, we're not given the context of east, west, north, south, anything like that. So we can't really put a negative answer on this. So we're going to take a look at the absolute value of this. So whatever answer we get, we're going to put this as a positive value right here. Okay? And when I punch that out in my calculator, I get 1.84 times 10 to the negative 25th kilogram meters per second. That's really all there is to it for momentum. So the problems we're having doing this separately, or maybe a couple of them that you have to add together, but this is pretty much all it is to momentum. So your assignment is 2 through 10 even on page 215. Have fun.